This video will discuss how to convert back and forth between rational exponents and radicals. So you might say, well, what do you mean by a rational exponent and where does it come from? First of all, with a rational exponent, remember that that represents a ratio, which would be anything which is in the form of a over b, where a is any real number. So what we're saying here is that any of your exponents could sometimes be written as a ratio, and we want to understand how to simplify them. So we're going to start with some simple examples. First of all, we all know that 5 squared is equal to 25. Right? So we can accept that and use that, which would mean that also that the square root of 25 is equal to 5. And that's going to be important for us as we work through our problems here, because what we're going to do is we're going to, instead of write 25, we're going to write the square root of 5 squared, right? Because 25 is the same thing as 5 squared. Thus, instead of 25, we can write 5 squared instead. So what we're going to do is we're going to change this up real quick. And we're going to try to change that square root into an exponent, because that's where our rational exponents come from. We know that the square root of 5 squared needs to equal 5. So if we took 5 squared instead, we said, well, what exponent is going to equal in order to have it equal to 5 as well? So we just changed this square root into writing something as an exponent. From here, what we do is that we say, well, we're going to use our power property, right? We know that if we have a power of a power, you can multiply those two things. So instead, this is going to look like a 5 times 2x is equal to 5. And write it as that equation instead. Power of a power, you multiply those things. Well, we have on the right side, this is 5 is equal to 1, or the power of 1 rather, which means that when we say we have 5 to the 2x is equal to 5 to the first, that means that really what we're saying is that 2x has to equal 1 and x is equal to 1/2. So we have just found the exponent that would go in here that would tell us what is equal to 5. So if we work all the way back, we say, well, this 5 squared is the same thing as 25, then what we have is 25 to the 1/2 is also equal to 5. And what we've stated is that 25 to the 1/2 is the same thing as the square root of 25. And this is a simple example of where our rational exponents come from. Remember, a rational exponent is something where it's a over b, and here we have 1 over 2 for 25 to the 1/2. And so radicals, or square roots, or any sort of root, could be written as a rational exponent instead. So we're going to look at another example that is the same thing. This time we're going to start with 4 cubed, and we should know that 4 cubed is equal to 64, which also would tell us that we would know that the cubed root of 64 is equal to 4. To kind of understand where these rational exponents come from, it's just a matter of rewriting things at first. So we're not really doing any sort of simplification or any sort of solving. We're just kind of showing how things can be written in different ways. And so 4 to the third equals 64, the same thing as the cubed root of 64 is equal to 4. And so if we take that 64 and write that instead as 4 cubed, then you can also say that you could do the cubed root of that 4 cubed, and that should equal 4. And so we're going to take that red cubed root there, and we're going to write it instead as some power. So how do you write a cubed root to what power is that? But it does still have to equal 4. And again, we know that our power property tells us that you can multiply this 3 times the x, and so what we would end up with is a 4 to the 3x is then equal to 4 as well. And that 4 on the right side would have to be to the first power. And so this is 3x equals 1 and x equals 1/3. So what we've just shown here is that if you actually have the cubed root of something, so if cubed root of 64, for example, that would be the same thing as saying that you have 64 to the 1/3. And then those would both have to equal 4. So perhaps you've actually known before why when we have the square root of x, why we call it the actual square root. It is going to turn into just x to the 1/2 if you want to rewrite it as a rational exponent. There has always been a little implied 2 here, and that's why we call it the square root, because it's undoing the squaring. But this is called a cubed root because it's undoing cubing, and so that would be x to the 1/3 written as a rational exponent. And finally, you have the 4th root of something, and so that would also be written as x to the 1/4. And so you have the square root as a 1/2, you have the cubed root as a power of 1/3, and a 4th root as a power of 1/4. That's how we would introduce where these rational exponents come from. One final thing to mention is how to state these roots. Often some students start to say something like the 3 times the square root because they think that this symbol stands for a square root. The symbol is actually called a radical symbol. Therefore, our description in words of what's actually happening has to change. So this would be called the square root. This is called the 3rd root of x, and this is a 4th root of x. So make sure to use that vocabulary as you're describing these problems.